Hey, what's up? It's Mr. E here, and in this video we're going to be looking at surface area and lateral area. So let's look at some formulas we're going to be using for this video. Here they are, formulas for lateral area and surface area. And we will begin with a lateral area problem. So example 1 says, find the lateral area of the cylinder below to the nearest hundredth. So the formula for the lateral area of a cylinder is L equals 2 pi RH. The radius is 12 and the height is 22. So you're going to substitute into the equation. So you get 2 times 12 times 22, that gives you 528 pi. And then 528 multiplied by pi is approximately 1,658.7605. It says to round to the nearest hundredth, so that means we're going to round to 2 decimal places. So we're going to round off to 2 decimal places, so our final answer is 1658.76. All right, let's talk a little bit about what is lateral area. So lateral area, let's look at a cylinder and how it's made up. So I got this, found this applet at mathopenref.com, and it's a nice way to look at what lateral area is for a cylinder. So a cylinder, if you take it apart, is made up of a rectangle and 2 circles. Let me put it back. You'll notice that we'll call it the width of the rectangle. The width of the rectangle is actually the circumference of the circle here. So the width of the rectangle is the circumference of the circle. So watch, when you unroll it, this 2 pi r is the formula for the circumference of the circle. And then this h here is just the height of the rectangle. So if you want the lateral area is just the rectangle part. So you just basically found the area of the rectangle part in the cylinder for example 1. So the lateral area is just the rectangle part, just this part over here, not including the area of those circles. That's what lateral area is for a cylinder. The surface area for the cylinder would have been the lateral area plus the area of the 2 circles. That would have been the total surface area of the cylinder. But they're not asking for that here. They just want the lateral area, and it's this here. And if you are going to talk about units, your units here should be feet squared because it's an area problem. So remember we said earlier that the units for area are squared. Let's look at another example. Example 2 says a right circular cone has an altitude of 10 feet and the diameter of the base is 6 feet as shown in the diagram below. Determine and state the lateral area of the cone to the nearest tenth of a square foot. So if you look at your formula for the right circular cone, if you want the lateral area, here's the formula. It's L equals pi r L, and L is the slant height. So I'm just going to write that formula down. So I'm going to say L equals pi r L, and then I'm just going to say over here, L, lowercase l, is the slant height. That's important for the lateral area of a cone. So when we substitute, we get 3 times radical 109. So at this point, you're wondering, what the heck? Where did that radical 109 come from? And let's talk about that. So you got to remember that in this formula, this L stands for slant height. This 10 is not the slant height. This is the slant height. So this is L right over here. So if you want L, you're going to have to go out and find it using the Pythagorean theorem. So let's highlight a couple of things. You have a right triangle here. And you're looking for the hypotenuse. So you know this leg is 3 because it's half of the diameter. And this leg is 10. So a squared plus b squared will give you L squared or c squared. So you substitute 3 squared plus 10 squared equals L squared, which is just the hypotenuse squared. Sorry about that, that was the bell. So you're going to get 9 plus 100 equals L squared. You're going to get 109 equals L squared. Square root both sides. You get L equals the square root of 109. And that's how I got the slant height. So when you multiply all this out, the pi times the 3 times radical 109, you should get approximately 98.39755. And if you're having trouble putting that in a calculator, all you really got to do is just type in pi times 3 times the square root of 109. Close the parentheses, and you get that. That should actually be a 57, right? 39757. Okay, so for the last part, it says to round to the nearest tenth, so that's 1 decimal place. So you're going to get L equals 98.4. That's your final answer. Okay, one more. It says if the surface area of a sphere is 144 pi square centimeters, what is the length of the diameter of the sphere? So the formula for the surface area of a sphere is 4 pi r squared. So we already know the surface area, it says, is equal to 144 pi. It says, what else does it say? Surface area is 144 pi, and I think that's all we got. That's all we got. So we're going to substitute for the surface area with 144 pi, and we're just going to write the rest. So you get 144 pi equals 4 pi r squared. This problem wants the diameter, but we could find the diameter if we find the radius. So what we're really looking for first is the radius. Once we find the radius, we'll figure out what the diameter is. So let's solve for the radius here. So we're going to divide both sides by 4 pi. So what's going to happen here is the 4's will cancel, and so will the pi's. And you'll just be left with r squared on the right side, and then the pi's will cancel here, and you'll be left with 36 equals r squared. So 6 is equal to the radius. So if the radius is equal to 6, that means the diameter is equal to 12, because the diameter is equal to twice the radius. So diameter equals twice the radius, 2r. So the answer is choice 3. Okay, so in case you're wondering what it means, what surface area means, picture a basketball, and for a sphere, excuse me. In case you're wondering what surface area for a sphere means, picture a basketball, which is a sphere, and surface area is basically the skin around the basketball. So that's what That's a nice way to think about surface area for a sphere. It's the skin part of the basketball. All right, so I hope this video helps. Have a good day.